you know, we took our time. Okay, so we're on number 17 and 19 in the warm-ups. You guys can find those. Evaluate each arithmetic series described. Arithmetic is sum equals n over 2 first term plus last term. Okay, so sum equals. All right, now this particular problem is telling you to go from term 1 to term 5. From term 1 to term 5 is 5 terms, 5 over 2. And then to get the first term, I'm going to plug 1 into the formula. And what should I plug into the formula to get the last term? 5. Beautiful. Okay, so negative 10 plus 30 is 20. 20 divided by 2 is 10 times 5 is 50. Great. Evaluate each geometric series described. That has a different formula. Sum equals first term times r to the n minus first term over r minus 1. Okay. Sum equals, what's the first term in the summation notation here? Negative 3. And what is r? Here's a hint. You can kind of tell that it looks like first term times r to the n, the way it looks right there. 3. So first term, r. And what's n in this problem? 7. Okay, now this is going to be a minus negative 3. Make sure that you have minus the negative or just put plus. I like to just put plus, but and then over 3 minus 1. Again, when you do this in the calculator, parentheses around the top and bottom. I don't know why I put the parentheses around the 2. If I was going to do the math, why did it? Anyway, it's fine. Negative 3279. Did anybody do this problem already and get negative 3279? Yeah, okay, thank you. Today's lesson is not about sequences or series. I know. Crazy town. Any questions about the warm-ups? No? Okay. If you could flip in your packet, please, to this page that says 10.3.2 resource page. Okay. Today is the first of a 2-day lesson about Pascal's triangle and the binomial theorem. What we're going to do is figure out how to expand binomials. Okay, first of all, what's a binomial? Give me an example of a binomial. What does bi mean? 2. So binomial will have 2 terms. So what would it be like? There's one up there, x plus y, 2x plus 5, a plus b, 4 plus 3x, 2x squared plus 9x. any two things that are added or subtracted, adding or subtracting that can't be combined is a binomial. You guys are really good about multiplying binomials because you're good at the box. So everyone in here knows how to do the forward box, the backward box, and all of that. We're going to not use the box with Pascal's triangle. What we're going to do is multiply out stuff like x plus y to the sixth without using boxes. So sort of. We're going to use boxes at first so I can show you the pattern, and then I'm going to show you how to use Pascal's triangle because it's faster than boxes. I brought a guest speaker today. He's behind me on the table, on the desk over there. He has a lot to say about Pascal's triangle. It's Pascal. I brought him because it's his day. So one of the reasons I love that movie is because he's named after a mathematician. Okay, homework tonight is 62 to 68. And here's my joke. This person was asked to expand a plus b to the n, and they expanded a plus b to the n. That's not what that meant, but pretty funny. Okay, but that is the type of problem that you will be doing, like expand a plus b to the n. It's just you're going to actually do it right. Okay. All righty. Start with this, please. And you're going to need a calculator.
Leah's too lazy to hand you this.
I hope it's okay that I put it directly into the trash can.
She wanted to do that.
You guys, I love you, really do. Have a lot to teach you, and I want to go over the quiz topics and things. So please, wrote it. It's not that much to write, honestly. I don't think everyone wrote it down yet. Once you get it written down, you can actually set your notebook to the side. We're going to go to the resource page first. Not like, geez, that was kind of dramatic, but okay. Okay. If you haven't written it yet, it's okay. I'm going to come back to it anyway. All right. So before we start anything, if you guys can look up at the screen, do you remember how to do these on your calculator? Yeah. Okay. So the first part of the first problem, number 151, we're going to do these on the calculator. So if you could locate the table for the resource page. This little guy here is NCR. N is the total, and R is the number of choices out of the total. Okay, so if you can find the math button, scroll over to probability, you'll find NPR and NCR. And we're going to work with NCR today, just the C, only the C. So if you go here, this box right here, it has the 0. Okay, can you guys look up here, please? Can you look at the screen? Can you look at the screen? Okay. This 0 is the N, and this 0 is the R. So if you guys could do 0, C, 0, that should come out to 1. That's this one right here. Okay, now let's do this box right here. This box is, now, okay, let me appeal to your laziness, everyone. Scroll up using the arrow key and then hit enter. And then you can scroll back and just change the values. So change this to 1C0, and that's 1. Okay, now this box. What would this box be in the calculator? 1C1. Scroll up, grab it. 1C1 is 1. Okay, now let's go to this box right here. What would this box be? Beautiful. 0C1. Okay. See what happens when you try to do 0C1 in the calculator. That doesn't work. Okay, let's think about why this box isn't actually possible. Because this is the total, N is the total, and R is the number of choices out of that total. Can you have more choices than your total? No. So what I'm saying is N always has to be the bigger number. So all of these boxes over here are not going to exist. Okay, let's go down to this line. Which one would this be? 2C0. We don't need to calculate it. We know it's 1. What would this one be? 2C1, 2C2. Okay, now let's go here. We're going to get to where we're actually going to do some stuff now. This box would be 3C0, 3C1, 3C2, 3C3. Now hold on. Let's be smart. Can you see what it's going to be without the calculator? With just the pattern in the table? It's going to be 1. You can tell it's going to be 1 because the diagonal pattern of 1's coming down in this direction. Also, what is this question asking? It's asking how many total choices can you have out of 3 things? How many ways can you choose 3 things out of 3 things? 1 way. Okay, so, but let's just verify because you guys think that Mrs. Talbot's making up some hoodoo over here. Here we go. 3C3 is 1. Okay. Now, here. This one would be 4C0. What do you think the value is without using the calculator? 1. This one would be 4C1. What do you think the value is without using the calculator? 4. Can you see the pattern here? Also, what's the question asking? It's asking how many different ways can you choose one object when you have 4 objects? 4 different ways. Okay, 6. Okay, take a look at the pattern in the table. What's this going to be? 4. Can you see the diagonal? 1, 2, 3, 4. And then this is going to be 1 again. And will this be a thing here? Does 4C5 exist? No. Okay. Now this is going to be fun. What's this number going to be? What? What's this number going to be? 5. Okay. What's this number going to be? 10. Okay, now you can do it in the calculator. It's 5C2. Go ahead and check it. but I can tell it's 10 because I looked up here and this went up 2 and up 3 and then up 4. Ah. Okay. What's this one going to be? 10. You can do 5C3 in the calculator, but if you go diagonal, you can see that it goes up 2, up 3, up 4, just like the other one. Okay, what's this one going to be? 5, 1. Okay, what's this? 1, 6, 15. Let's just verify. Yep. What do you think? $20. Anyone have any idea why it's 20? This one went up 3, up 6, and then up 10, just like this pattern here, 3, 6, 10. Very challenging. This is why we go to the calculator after a hot minute. Okay, 64. What is it? 15. Okay, I'm hoping that you notice there's some symmetry here. 6, 1. Okay, I want you guys in your groups to do the last 2 rows, please. And then once you get your values, enter them down here in the triangle. Don't look at the screen till you're ready. Okay, so do you see the pattern over here? 1, 3, 6, 10, 15. So up 3, up 6, up 10, up 15, up 21. It's adding each time this pattern here. Actually, okay. Once you guys get this, what I want you to do is come down to the actual, this is Pascal's triangle right here. Enter the same values in down there. This is a much better representation of it for a bunch of reasons. First, it shows the symmetry. So you guys should be able to cut that triangle right down the middle and see that it reflects on either side. It also shows you how to build it. Okay, so I'm going to show you a trick. It's not a trick. It's a technique that you're going to need to be able to do this with no calculator, no notes, say on a quiz or something. Okay, this is a skill that you need to have. How do I build Pascal's triangle from scratch with no calculator? Are you ready? You don't need to copy these numbers off of me. You have them in your table. They're the same numbers. Okay, please watch. This is extremely important. At the top of Pascal's triangle, there's a 1. He's just, he's making sure that I'm doing it correctly. Okay. And then the next row has 2 1s. Okay, can you memorize that part? Okay. Now, the third row, it's actually row 2. This is called row 0, row 1. We're going to label on ours, but that's okay. Starts with a 1. Then what you do is you add these 2 numbers, and then it ends with a 1. Okay, watch again. Start with a 1, add these 2, add these 2, end with a 1. Start with a 1, add these 2, add these 2, add these 2, end with a 1. Am I making the triangle? Yes. 1, add, 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 1. Do you get how to? Okay, I'm gonna do one more. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And with a 1. Okay, we're going to represent this on our triangle in a couple of ways. First thing we're going to do is call this row 0, row 1, row 2, row 3, row 4, row 5, row 6, row 7. You can tell what row you're in from the first number in the triangle that's not a 1. They all start with 1. So the next number in is going to be the row number. Also, I'm going to use a highlighter. You guys can use whatever you want. We're going to show what I just did on the blank sheet of paper. Just pick any 2. Four plus 6 equals 10. So show it any way that you want to, and it doesn't have to be 4 and 6 and 10, but just show that the 2 above add to the 1 below. Okay, when you're done with that, flip to the back. Okay, and this back is really just a reference page for you. This is what you would get if you searched images of Pascal's triangle. This is the first part of the triangle. This is that same part of the triangle, but it has the NCRs filled in, like we did the math earlier for number 151. This is really helpful. It's got the rows, and then also it's telling you this is the 0th, first, second, and third. We're going to come back to this at a later time. This one is how we show NCR in stats class. So if you take AP stats, I'm not going to write 5C2. I'm going to write, well, it would be down here, but I'd write a big parenthesis with a 5 over a 2. It's just different notation. And then this last bit, what? We don't do P. And then this last bit is actually where we're going. So we're not here yet. This is expanded form properly, not what Bob did on his quiz there on the joke. Okay, so you guys are done with the packet. I would not put it away. I would actually, if I were you, turn it back over to the triangle we made and then just set it to the side here. Okay. Now we're going to start with binomial expansion using Pascal's triangle. He's very excited about it, as you can tell from his expression. Sorry. So we're going to expand with boxes first, because that's what you guys know best. You guys are all about the boxes. Everyone that's been to Benicia, any kind of elementary school, middle school, or high school, is all about area models. So we're going to use area models. There are people in this class who will say to themselves, I can't learn what just Mrs. Talbot just taught me. I'm going to do area models for everything. And I don't suggest that, but you know, it's not my life. You can do that if you want to. Okay, anyway, does this make sense so far? Okay, so because, you know, we're really good at area models here in our class, we're going to draw a 2 by 2. A plus B, A plus B. And this would be A squared, AB. I highly suggest when you're doing your area models, I mean, we're not going to do area models for this for long, but if you have 2 letters, put them in alphabetical order, because then it's easier to see that these are like terms. Okay, do you have any questions about what I did so far? Does that make sense? Okay, now this is where I'm hoping to start blowing your mind. 2. I forgot the 2 because it's Monday and I haven't taught anything in like over a week. Okay, so this is your final answer. This is all good. Like this problem is done, but I sort of want to step backwards here on purpose. I want you to look at these numbers. And then I want you to link that back to the triangle on the resource page. Do you see those numbers? Do you see 1, 2, 1? What row is that? Row 2. Okay, do you see the 1, 2, 1? And you're looking right here at the 1, 2, 1, and that is row 2. Okay, my hope for you is that you're going to be able to get row 2 from the exponent. So the exponent is going to tell you that you're in row 2. You're going to be able to write this off of Pascal's triangle without making the box. That is the end game. But we're going backwards right now for you to trust me that Pascal's triangle works. Okay. Okay, now I'm going to cheat a little bit. Are you guys okay with me taking this part, this baby part here from the answer above? So do you see how that is this? Okay, so right underneath there, I'm going to write a squared plus 2ab plus b squared. That is from this where I already expanded that part. And now I have a third one this time because this is a plus b cubed. So I already multiplied the first two in this box up here. And now I have a third one. What size box is this going to be? 3 by 2. Good job, Nolan. So 1, 2, 3, 1, 2, 3. Remember about the alphabetical order thing I was saying? Any questions about my expansion using the box? I got a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, what are the leading coefficients here? Yep, 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. 1, 3, 3, 1 are my leading coefficients. Okay, what row is that? Row 3. And what in my initial problem should indicate to me that I would be working in row 3? Cubed. Okay, are you with me so far? Are you willing to believe that the squared exponent will give me row 2 in Pascal's triangle, and the cubed exponent will give me row 3 in Pascal's triangle? Are you with me? Okay, now we're going to depart from boxes, because once you get to the fourth power, I would be unwilling to do boxes after this. What we need to do is say, okay, Mrs. Talbot, I get about the numbers in the front. I get that I can tell what row I'm in from the numbers in the front. What I need to show you now is, how do I get all the letters? Okay, are you ready? C. First, what row in Pascal's triangle I be in? Row 4. Okay, and I have 2 questions for you. How many terms are there in row 4? 5 terms. How can you answer that question? Okay, so you go to row 4, and you go 1, 2, 3, 4, 5. There's going to be 5 terms. You guys should all know that there's just going to be one more term than the row number. So if it's row 4, there's going to be 5. If it's row 7, there's going to be 8. Okay, what are the leading coefficients of those 5 terms? 1, 4, 6, 4, 1. Okay, this is not the end of the problem. I'm just setting it up. Any questions about how I got any of those things? You good with that? Okay, this is the new part that you need to learn. We need to learn, okay, we know what the numbers in front are going to be. What happens to the letters? Okay, first you start with the 1. So you start with the first one. You take a to the full power. So what I mean by that is a to the total power of 4. and then b to the 0 plus next number in front is going to be 4. The front seat, okay, first of all, I like to call these things front seat and back seat. Do you see the front seat and the back seat? Okay, the front seat thing is going to go down a power. The back seat thing is going to go up a power. Do you see how they all will add to 4 when I'm done with them? So 4 plus 0 is 4. 3 plus 1 is 4. Okay. Next one is going to be 6. Front seat thing goes down a power. Back seat thing goes up a power. Is there a total of 4? Yes. Plus 4. Front seat thing goes down a power. Back seat thing goes up a power. Plus 1. Front seat down, back seat up. Okay, now we're just going to clean this up. This is a 1, correct? What is b to the 0? 1. Okay, so I'm going to just lightly cross those out. The front is just going to be a to the 4th. This one is a cubed b. We don't really write the 1 for b to the 1st. A squared b squared. 4ab cubed. Okay, and then this one, the 1 and the 1. So I just expanded a binomial using Pascal's triangle and not using boxes. Okay, we have one more problem. A plus b to the 6th. It's going to be a bit tedious. Tomorrow, my goal is to teach you how to do this when it's not a and b, when it's like x and 5 or 3x and -2 or 27x cubed and 9 smiley face to the 4th. I don't know. I just made that up. I was trying to make Pascal laugh, but he's impossible. Okay. Last one. First, what row am I in? Row 6. How many terms will there be? 7 terms. What are the leading coefficients? 1, 6, 15, 20, 15, 6, 1. Any questions about that part? Do you know where all this stuff came from? Yes? If you're stranded on a deserted island, could you find these by creating Pascal's triangle with a stick in the sand? Hopefully. Okay. Now, equals. Start with the 1. Front seat thing to the full power. Back seat thing to the 0. Plus 6. Front seat down a power. Back seat up a power. Okay. What's the next one going to be? Anyone feel comfortable telling me? 15. 15a to the 4th. B to the 2. Is that what you said? Okay. Anyone else feel comfortable telling me the next one? Tyler? Anyone feel comfortable telling me the next one? Anyone other than the two of you? Perfection. Someone else? Someone other than Tyler, but you said it. Okay, last one is 1, a to the 0, b to the 6. Okay, now we just need to clean it up. A to the 6 plus 6, a to the 5th, b. 15, a to the 4th, b squared. By the way, if you're doing this and you're able to just not write the things with the ones, that's okay. You can skip directly to this step if you're good at it already. You won't be able to do that forever because they're not always just going to be A and B, but for today you might be able to. Okay, that's the end of the notes. So make sure you are situated there. Then I want to put the quiz topics up. I don't know if you guys noticed, they posted this morning. Okay. Let's talk about the quiz. Quiz on Wednesday. Notice it says no notes allowed, but it doesn't say anything about calculators. You will have to use a calculator this time. We have to relent and let you use a calculator. Okay. You have 3 questions. Finding the sum of finite. Okay, finite is the opposite of infinite. Finite is the regular ones. So when you see the word finite, it just means like regular geometric. So finding the sum of regular geometric and infinite geometric. So that's just, literally like what we, plug in the formula. The number of terms in an arithmetic, that's the quad formula thing. Do not study that. I have an optional review for you also before you leave. And then drafting trig function, sine and cosine waves. You guys know what I mean when I say the quad formula thing?
Yeah.
Okay, now I want to show you one more thing before we're done. And then I'll put the optional practice on the cart. I didn't want to put it up there before because of your tendency to do it while I'm talking, which really annoys me. But okay, if you guys could look at this, please. This is the top of the quiz. Okay, so you have the sum of an arithmetic, you have the sum of a finite geometric, that just means regular. You have the sum of an infinite geometric, and you have the quad formula. Okay, so I just wanted you to know that these would be here and you'll have a calculator. All right.